Today we're going to be talking about sequences and series. So we'll start off with arithmetic sequences, and you've got a couple of formulas, so make sure that you're aware of these. And of course, with the nth term formula, you can distribute the d and combine any like terms. And you'll notice that this is a linear equation, so if you have a linear relationship, then it's an arithmetic sequence. And we can also find the sum of the first terms. Okay, so in your problems on these, like I said, we're just talking about arithmetic sequences, so you know in advance that it's arithmetic, but if you didn't, always look for clues like if it says arithmetic or if you have to come up with it being linear. And then that's going to tell you that you can use this formula. All right, so in this question, it's asking two different questions. It's saying, find the 51st term and find the nth term. Okay, so the nth term is just going to be the equation, and the 51st we're going to plug in. So we have an initial term, A1 is 5, and we have a common difference D. So we've got this, and we've got this. So initially we're just finding the nth term, so let's plug those in. And then we'll simplify our equation. You can distribute -3, combine your like terms. So that gives us a formula in terms of n, so that's our generic nth term. So we can find any term in this sequence. So let's find the 51st term. So what that's saying is that our n value is 51. So we're going to use our same formula, plug in 51, and find the value. In the next example, again, it says arithmetic. So now you know the formula you're allowed to use. This time it says to find the first term and the common difference. So we know the 8th term and we know the 20th term. So what we can do is we can use both of those and we'll set up a system of equations. So we know this information. So if the 8th term is 8, we can write it this way. And if the 20th term is 44, we can write it this way. And each one I distributed combined like terms as necessary. Okay, so now we have two equations with A1 and D as our variables. We can solve that system of equations. Okay, you can use whatever method you like. I decided to go with substitution, but you could use elimination if you wanted to. So go ahead and solve the system. And you should come up with the common difference D being 3 and the first term being -13. And that's what's being asked in the first question. Now in the second question, it's asking what's the nth term of the sequence. So then we'll go back to our initial formula. Now that we know A sub 1 and we know D, we can write our equation with A sub n and n. So we'll plug in like that and then simplify. Okay, in the third example, instead of being told, here's a sequence, we're given the actual sequence. And so what we need to do first is we need to decide, if we hadn't already known, we need to decide if it's arithmetic or not. And so we'll look at the relationship. To go from 2 to 4, you could try adding 2. And then we'll test it out. To go from 4 to 6, yep, we can add 2 again. So what that tells us is that it is arithmetic because we have the same difference each time, a common difference, and that common difference is 2. Then some other pieces that we'll need the first term. So the first term is 2, that's A sub 1, and we also have a last term, that's A sub n. Okay, and we're trying to find the sum of all the numbers, and we don't want to have to sit there and plug into our calculator from 2 until 70. So ultimately we're going to use this sum formula. But for the sum formula, we need to know how many there are, n. We know what the last one is, but we don't know how many there are. We know the first and the last. So what we need is n, so we'll use the first equation to do that. Because we know the first term, we know the last term, and we know the common difference d. So we can solve that one for n. So we'll put everything in, and then go ahead and solve it. Okay, now we know n is 35. Now we can use the sum formula to say 35 divided by 2 times the sum of the first and last terms. And just go ahead and plug into your calculator. Okay, so if you had sat there adding 2, 4, 6, 8, 10, all the way until 70, and you hadn't made any mistakes in all of those calculations, you would get the same thing. But that's not efficient. That's why we want our formulas. All right, so again, we're looking for the sum, but this is given in a different way. The last one we could see the sequence. This time we have a formula for the sequence. So some pieces that you need to understand. This is summation notation. When you see that symbol, the symbol means sum, means add things. And it always tells you where to start. The bottom is where to start. So in this case, n equals 1. We're going to start there. And then the top is where you're going to end. So we're going to stop at 120. Okay, and we're going to keep on plugging in. So just like the last one, we don't want to have to keep plugging in. So we'll set up an equation. Okay, so on this one, we know our d. Okay, our d is 2, and that's from the equation. When it's linear, remember the common difference is basically the slope from your linear equation. That's also telling us that it's arithmetic. And we can find the first term by plugging in 1 as stated here. Right? It says n equals 1. So we're going to plug that into the formula, and that'll give us our first term. Okay, so now we have the first term, we have the number of terms, that's up here, and we have our common difference. Okay, so now let's use that information to find the sum of the series. So you'll substitute in and calculate. Okay, in our next example, we again have a series listed out, a sequence listed out, and you can check to see that it's arithmetic by looking to see if you have the common difference each time. So to get from 8 to 11, you have to add 3, then add 3, then add 3. So because of that, we know it's arithmetic, and we know that the common difference, d, is 3. From this, we also know our first term is 8, our a sub 1, and we know we're looking for the first 80 terms, so that's your n value, 80. Okay, we're looking for the sum here. We need n, we need a sub 1, we need a sub n. We have n and a sub 1, we just need to find a sub n now. In order to do that, we can use our formula up here. Okay, we'll plug in everything that we know, and that's everything except for our a sub n. And now, calculate it out. Now we know a sub n, so we're ready to plug into our sum formula. So the key here isn't in the calculations. That's not the difficult part. The difficult part is knowing which equation to use and when. Okay, so now you can see you have a summary of all of the different geometric equations that we have, and there are a lot more. We only had the 2 equations for arithmetic, and now we have all these geometric. So we're going to be using these on the next examples. So now we're looking at the geometric sequence. So when you see that term geometric, you know to use one of the geometric equations. Okay, and so on this one, we're looking for the 5th term and the nth term. So we'll do both of these. And we're given our first term, and we're given the common ratio. So we can plug into the formula, and then that gives you your nth term. Now be very careful, because this is actually fully simplified. If you remember your order of operations, please excuse my dear Aunt Sally, remember you have to do the exponents before you can multiply. So you cannot multiply the 2 times the 3. That would not be equivalent. Okay, so that's our nth term. To find the 5th term, then you'll just need to plug in 5 for n and calculate. On the next one, we're given the sequence, and this time if you try to find a common difference, to go from -3 to 1, you would have to add 4. And then to go from 1 to -1/3, you can't add 4. So what we can do instead is we can divide. To go from -3 to 1, we're dividing by -3. Then to go from 1 to -1/3, we're dividing by -3 again. And then again to get to 1/9. Okay, so that tells us this time it's not a common difference, because difference implies you can add and subtract. This is a common ratio, so we'll call it R for ratio. And it's saying find the nth term. We need to know that we're using the nth term equation again. And we know the first term is -3. And we know the common ratio is -1/3. What we don't know is n, but since we're finding the nth term, that means we're going to leave n in the final answer. Okay, so just like before, we can't multiply the -3 and the -1/3. It looks like we can, but we can't, if we remember our order of operations. But we can rewrite this. And in order to do so, we'll have to remember our rules of logs and exponents. Specifically, in this case, we're going to use our exponent rule with negative powers so that we don't have this fraction in here. So we can write this 1/3 as 3 to the -1 or -3 to the -1. Alternatively, you can write the outside number, -3, as -1/3 to the -1. So now we have these matching bases. And we can combine them together here. Remember, we're combining them together because we're multiplying two powers with the same base. If they have the same base, you keep the base and you add the powers. So -1 plus n minus 1. Okay, and there are a few alternate forms of the answer that you could come up with, but this is one form. All right, and in our last example, we're told that we have a geometric sequence. Okay, and we're finding the nth term, so we're going to use our nth term equation. And so let's see, we have the sixth term and we have the common ratio. Okay, so knowing the sixth term, we can say, okay, well, when n is 6, the sixth term is 243. All right, so we'll plug into our formula. And be careful, we can't divide both sides by 3 because this is a base. We can't do that. But we can find out what -3 to the 5th power is. And then we can divide. Now we know our first term, so now we can plug back in. And again, we can't multiply the -1 and the -3.